Okay, this is our second video on L'Hopital's rule, and we're going to work on a couple more examples. Look at a couple other techniques. So we're going to look at the limit as x approaches 0 of e to the x minus 5 to the x all over x. And so if we try to directly substitute 0 in, e to the 0 and 5 to the 0, those are both 1. So you have 1 minus 1 over 0, so that's the indeterminate form, 0 over 0. So this is a candidate for L'Hopital's rule. So there's going to be a limit as x approaches 0. Derivative of e to the x is e to the x, minus the derivative of 5 to the x is going to be the natural log of the base, 5, times 5 to the x, all over 1. But we didn't write that there. And now we can directly substitute. So this is e to the 0 minus the natural log of 5 times 5 to the 0. So it's going to be 1 minus the natural log of 5. Okay. All right, let's look at another one. We're going to look at the limit as x approaches infinity of x times the tangent of 1 over x. So the x is going to infinity, and then we have tangent of 1 over x, so that's going to be 1 over a very large number, which is going to be pretty much 0. The tangent of 0 is going to be 0, so we have the form infinity times 0. And so what we're going to do is going to rewrite the x as a 1 over x, so tangent of 1 over x divided by 1 over x, okay, so that's equivalent. And then you're going to have 0 over 0 now. So once we have 0 over 0, then we can apply L'Hopital's rule. So it's the limit as x approaches infinity of the secant squared of 1 over x times negative 1 over x squared by the chain rule. Derivative of 1 over x is negative 1 over x squared. The negative 1 over x squared factors will absorb, and so then we'll just have essentially the secant of 0, because x is going to infinity, so we have 1 divided by a big number that's very small. So we have the secant squared of 0, and secant squared of 0 is 1. Okay? Alrighty, we got one more example to take a look at here. So we're going to look at the limit as x approaches infinity of 1 plus 1 over x to the x. Okay? When we try to directly substitute a very big number, this is going to be 1 raised to the infinity, so that's an indeterminate form. We can only apply L'Hopital's rule if it's 0 over 0 or plus or minus infinity over plus and minus infinity. So the strategy here is we're going to assume that the limit exists, and we're going to call it y, and then we're going to apply the natural log to both sides of this equation here. Okay. And then we're going to use the fact that the natural log is continuous to slide the natural log past the limit so that we can take out the exponent. So this is why we want to use, it kind of looks like an absolute value. This is supposed to be a parentheses. Whoops. This is why we want to use the natural log, is because of the power rule. Oh, that didn't look any better. Okay, there we go. So we want to use the power rule to bring the exponent down. So that's what we're going to do here. So this is going to be limit as x approaches infinity of x times the natural log of 1 plus 1 over x. That's going to be equal to the natural log of y. Now if we take a look at what we have, it's going to be a very large number times the natural log of basically 1. So it's going to be infinity times 0, and so that's still an indeterminate form. But now what we can do is, like in the previous example, we'll write x as 1 over x. So this is the limit as x approaches infinity of the natural log of 1 plus 1 over x divided by 1 over x, and that's going to be equal to the natural log of y. So now we have our form of ln of 1 over basically 0, so that's going to be 0 over 0. So now we can apply L'Hopital's rule. So that's going to be 1 over 1 plus 1 over x, and then by the chain rule, negative 1 over x squared. Derivative of the bottom is going to be negative 1 over x squared, equals the natural log of y. All right, so now we have the limit as x approaches infinity of 1 over 1 plus 1 over x. That's going to be equal to the natural log of y. So 1 is going to be equal to the natural log of y as x goes to infinity. So the y must be going to e because the natural log of e is 1. So the limit as x approaches infinity of 1 plus 1 over x raised to the x power is equal to e. And quite possibly you've seen the exponential defined as this limit in one of your math classes in the past. Alrighty, well, we'll see you next time.